Hello everyone and welcome back to Gaming and Chatting. Right now you exist in one universe, but what if that's not the whole story? What if this universe, everything we can see, measure, and experience is only a single region of a much larger reality? A reality where other universes exist. The laws of physics can change. Every possible outcome may actually occur. It's called the multiverse. And it emerges naturally from some of our best theories of physics. The multiverse isn't one theory. It's a family of ideas, all suggesting that what we call the universe might not be everything. Physicists didn't invent the multiverse because it sounds cool. They were forced into it by problems they couldn't otherwise solve. Problems like why the laws of physics seem perfectly tuned for life, why quantum mechanics allows multiple outcomes, why the early universe expanded the way it did. Each of these independently points toward more than one universe. Why physicists even consider a multiverse? Let's start with something unsettling. The universe appears finely tuned. Small changes to fundamental constants would destroy it, if gravity were slightly stronger. Stars burn too fast, slightly weaker. Galaxies never form. Change the cosmological constant. Space expands too quickly for matter to clump. Change particle masses. Chemistry fails. These aren't minor changes, they're catastrophic. So the question is simple. Why do the laws of physics have exactly these values? The fine-tuning problem. There are only three logical explanations for fine-tuning. 1. Necessity. The constants couldn't be different. 2. Design. They were intentionally chosen. 3. Chance. They vary across many universes. Physics strongly prefers explanations that don't invoke intention. That leaves chance. But chance only works if there are many trials, which means many universes. This idea is formalized as the anthropic principle. It says, we should not be surprised to observe conditions compatible with our existence. If millions of universes exist, most are lifeless. A few allow complexity. Observers necessarily arise in those few. So the universe looks fine-tuned not because it was designed, but because only fine-tuned universes can be observed. This reasoning is uncomfortable, but it's logically consistent. Level 1 Multiverse. Beyond the cosmic horizon. The simplest multiverse is also the least controversial. It says, space may be infinite. We can only see a finite region because light travels at a finite speed. Beyond our cosmic horizon, space continues. Matter rearranges itself in different ways. If space is infinite, every possible configuration of matter occurs somewhere, including regions identical to Earth, including copies of you. Same laws, same constants, different initial conditions. This isn't speculation. It's a direct consequence of infinite space. Level 2, Multiverse. Inflationary bubbles. Now we go deeper. Inflation. Inflation theory explains why the universe is flat, uniform, structurally smooth. It proposes that the early universe expanded exponentially fast. Inflation works extremely well, but many models predict something else. Eternal inflation. Inflation may never fully stop. Instead, it ends locally, creating bubble universes, while continuing elsewhere forever. Each bubble is a universe. And here's the key. Each bubble may have different physical constants. Why this solves fine-tuning. In a bubble multiverse, laws of physics vary. Most universes are lifeless, some are stable. We live in one of the rare bubbles where stars form, chemistry works, life is possible, fine-tuning becomes selection, not mystery. Level 3 Multiverse. Many worlds of quantum mechanics. Quantum mechanics introduces another multiverse. The measurement problem. Quantum systems exist in superpositions. But when measured, we see one outcome. Why? The many worlds interpretation. Many worlds says the wave function never collapses. Instead, every outcome happens. The universe branches. Each branch contains a different result. Every quantum decision creates parallel histories. No randomness, no collapse. Just branching reality. Are these really other universes? Some argue these branches are mathematical, not physically real. Others argue they never interact, have separate histories, and are effectively separate universes. Either way, the mathematics work. That's why physicists take this seriously. Level 4, Multiverse. Mathematical reality. This is the most radical version. It proposes every mathematically consistent structure exists physically. In this view, reality is mathematics. Physics doesn't describe reality, it is reality. Every possible universe defined by math exists. Our universe is just one structure among infinitely many. This idea is deeply controversial, but it addresses a haunting question. Why does mathematics describe the universe so well? String theory and the landscape. String theory strengthens the multiverse case. It predicts extra dimensions, many ways to compact them, each yielding different physics. This creates the string landscape, possibly 10 to the power of 500 different vacuum states, each corresponding to a different universe. Vacuum energy varies across this landscape. This ties directly into dark energy, the vacuum catastrophe, and fine-tuning. Can the multiverse be tested? This is the biggest criticism. If other universes are unobservable, is the multiverse scientific? Possible tests include statistical predictions, constraints on constants, imprints from bubble collisions. So far, no direct evidence, no definitive falsification. This keeps the debate alive. Science or philosophy? Some physicists say the multiverse is unavoidable. Rejecting it requires rejecting successful theories. Others say it undermines scientific explanation. It replaces prediction with selection. Both sides include Nobel laureates. This isn't fringe. It's an open debate at the foundation of physics. The multiverse may sound outrageous, but it emerges naturally when we take mathematics seriously, push theories to their limits, refuse to stop where intuition feels comfortable. Reality may be far larger than a single universe, and if that's true, then the universe we call home is not the whole story, just the one where we happen to wake up. If you enjoyed this chat, like the video and subscribe, and let me know in the comments. Do you think the multiverse is real physics, or is it the point where science becomes philosophy? I will chat with all of you in the next one. Bye for now.